Welcome to Cosmic Compass, the place where we navigate the vastness of space together. From distant galaxies to the hidden stories of our own solar system, we unfold the universe one mystery at a time. Today, let's journey into one of humanity's boldest engineering feats, the story of the James Webb Space Telescope, and how it unfolded into the eye that sees farther than ever before. For decades, humanity dreamed of peering deeper into the universe to witness the first stars and galaxies that ever formed. That dream was fragile, wrapped into a telescope so ambitious, so expensive and so complex that some doubted it would ever fly. 20 years in the making with a price tag of $10 billion, the James Webb Space Telescope carried the weight of a generation's hopes, and yet all of it depended on a single launch. Imagine this one misfire, one malfunction, and Webb would become little more than twisted metal, drifting in silence. No second chances, no repairs, just failure written across the stars. But history remembers boldness, and on that December day, the rocket roared to life. Against the odds, Webb left Earth behind. Still, success was far from certain. Ahead stretched weeks of tension, moments where one wrong movement could end the mission forever. So what exactly did Webb have to do? Let's retrace that journey together from its fiery departure atop a rocket through the delicate dance of unfolding itself in space all the way to its final resting point, a place where gravity, light and science converge. By the end, you'll see why Webb's story is not just one of engineering, but of human perseverance. Webb's journey began aboard the Ariane 5, one of Europe's greatest contributions to the mission. The telescope itself was practically designed around this rocket chosen for its reliability. First, the liquid-fueled main stage ignited, joined seconds later by two towering solid-fuel boosters. Each booster weighed nearly 300 tons. For those first minutes, sheer brute force was needed to overcome Earth's grip. Solid fuel may lack finesse, but it delivers raw, unstoppable thrust, the kind you want when lifting a priceless observatory skyward. 75 kilometers up, the boosters exhausted their charge and fell away, left to plunge into the ocean. By then, the main engine carried Webb alone, its liquid fuel burning hot, able to throttle and adapt as needed. Once the rocket pierced past the Kármán line at 100 kilometers, the fairing protecting Webb was discarded. There was no more atmosphere to fight against, no debris to shield from. For the first time, Webb was exposed to space. After 8.5 minutes, the main stage too fell away. Piece by piece, the rocket shed its weight, leaving only the upper stage to push Webb toward its destination. Yet even this moment wasn't without danger. Sunlight now touched the folded telescope directly. Without its sunshield deployed, Webb's instruments risked heating up. To survive, the upper stage gently rocked the spacecraft back and forth, cradling it like a baby to spread the heat evenly. Half an hour after liftoff, the upper stage shut down. There was a moment of stillness, then separation. Webb drifted free into the darkness alone for the very first time. The mission had only just begun. When Webb detached from its rocket, the world held its breath. This was the last time human eyes would ever directly see the telescope. From here on, only telemetry data and trust in engineering would speak. Almost immediately, Webb fired its thrusters, a small but historic sight, then unfolded its solar panels. Power was flowing. Life had begun. What could have been a moment of chaos instead passed smoothly. Separation had introduced almost no unwanted spin, so Webb didn't have to fight to stabilize itself. That meant its panels deployed earlier than expected. A good omen, perhaps, in a mission where so much could go wrong. From this moment onward, Webb steered itself. Its thrusters kept performing that gentle cradling maneuver, ensuring sensitive instruments stayed as cool as possible. Every motion was deliberate, every adjustment measured. A day and a half later, another key step, Webb's high-gain antenna, extended the crucial link for sending its story back to Earth. By now the telescope had already crossed beyond the Moon's orbit further from home than many spacecraft had ever travelled. Yet paradoxically, Webb was slowing down. Fighting Earth's pull head-on required energy, and gravity never let go easily. 3 days in it was time for the next trial, the beginning of deployment. And this was where things could truly unravel. Because unfolding Webb wasn't a single event. It was a sequence of over 300 potential failure points, each depending on the last. If one jammed, tore or snagged, the telescope would be lost. Let's walk through those steps one by one. On day 3, the first movements began. Slowly the sunshield pallets opened like book covers, parting to reveal delicate pages inside. These initial steps seemed minor, but they set the stage for the most fragile deployment in space history. By day 5, Webb extended the tower assembly, lifting the telescope away from where the sunshield would unfold. This separation was essential. Without it, heat from the spacecraft could seep into the instruments, ruining their cryogenic precision. Alongside it, a clever addition appeared, the aft momentum flap. Though small, it would save fuel by counterbalancing the push of sunlight on the massive sunshield. Every gram of propellant Webb conserved meant more years of science. Then came the moment everyone feared, the sunshield itself. 5 wafer-thin membranes, each thinner than a human hair, together spanning the size of a tennis court. These layers were Webb's lifeline, designed to block the sun's heat and cool the telescope to nearly minus 230 degrees Celsius. In 2018, a test deployment had torn the membrane. If such a tear happened in space, Webb would never reach the frigid temperatures it needed. Every inch of unfolding had to be flawless. First, protective covers unrolled. Next, 2 booms extended outward, pulling the membranes into their vast, fragile shape. Each sheet, then, had to be tensioned, stretched gently but firmly until the layers lay flat. The operation lasted days. Controllers on Earth moved slowly, carefully, often pausing to check and recheck before continuing. At last, the membranes held firm. One side of Webb now faced scorching sunlight, heating above the boiling point of water. The other, the side with the instruments chilled into deep space, colder than Antarctica in darkness. With the telescope shielded, more components came to life. Around day 10, Webb's secondary mirror extended on its long arms, snapping into place. Without this mirror, no light could ever be focused onto the instruments. Soon after, the aft radiator deployed a passive cooling system, radiating heat from the instruments into space. Finally, on days 12 through 15, the most visible transformation occurred. 2 great wings of the primary mirror, folded for launch, swung outward and locked in. Piece by piece, Webb revealed itself. What had launched as a compact bundle now blossomed into a golden flower, its hexagonal mirrors gleaming against the void. By day 15, the deployment was complete. Webb was whole. Humanity's most ambitious observatory had taken shape in space, but its work was not done. Not with its structure in place, Webb still needed a destination. Unlike Hubble, which orbits Earth, Webb was bound for a more distant perch, the second Lagrange point, or L2. Let's pause here. What exactly is L2? Imagine Earth and the Sun pulling on a spacecraft with their combined gravity. At certain points, these pulls and the orbital motion balance perfectly. L2 is one of them, a spot about 1.5 million kilometers away, directly opposite the Sun. From here, the Sun, Earth and Moon always line up, on one side safely hidden behind Webb's sunshield. To the telescope, The only bright planet it would ever see directly was Jupiter. After nearly a month in flight, Webb made its final course correction. Thrusters nudged it into a gentle halo orbit around L2. Not too close, not too far, just balanced, like a surfer riding a wave of gravity. Yet, even then, Webb wasn't ready for science. Each of its 18 golden mirror segments had to be aligned to nanometer precision. Engineers painstakingly adjusted them, turning blurred patterns of starlight into sharp, unified images. This alignment alone took weeks. By day 29, Webb was stable in orbit. By 160 days, its instruments had cooled enough to function at peak performance. The telescope was ready. The risk-filled journey was over. Ahead stretched a future of discovery. From that moment onward, the James Webb Space Telescope began to collect light older than humanity itself. Every photon captured carried whispers from the dawn of time, from galaxies formed just a few 100 million years after the Big Bang. But Webb's story is not just about the telescope. It is about us, our willingness to risk, to wait, to trust that something so intricate and unlikely could succeed. For 20 years, the world held its breath, and now we can finally exhale. Of course, Webb is not alone. Space is filled with eyes. We've launched over decades. Hubble still orbiting Earth, Kepler, which revealed thousands of exoplanets, Spitzer peering into infrared mysteries, and Gaia charting billions of stars in our Milky Way. Each mission, a chapter each, a step in humanity's quest to understand the cosmos. And yet Webb stands apart. With its unmatched power and its daring design, it has already redefined what we can see. For the next decade or more, it will show us where we came from and perhaps where we are going. So let's look forward together. Because every image Webb returns is more than just data. It's a mirror reflecting our own desire to explore, to understand, and to unfold the universe. That was today's journey across the cosmos. If you enjoyed this exploration, let's keep traveling together. Subscribe to Cosmic Compass, leave a like, and share your thoughts in the comments below. What part of Webb's story amazed you the most? Until next time, keep your eyes to the stars, and let's continue unfolding the universe, one story at a time.